Hello, you guys. Let's continue with mathematics part 2. What is the limit shown below? Limit of x converges to 1 of 4x power 4 minus 2x power 3 plus x squared minus 3 over 5x cubed minus 4x squared minus 1. So first, what we're going to do here, we're going to substitute x with 1 to see what are we getting. So if you do that, I'm going to let you do that by yourself. Eventually, what you're going to get is 0 over 0, which is an undetermined case. And when we have this, we use L'Hopital rule. We have L'Hopital rule in the FE handbook. I'm going to come to the FE handbook and write L'Hopital rule. And eventually what L'Hopital rule tells you is when you have these undeterminate cases or forms, 0 over 0 or infinite over infinite, what you do in order to solve the limit, you take the first derivatives of both functions. And if that gives you an indeterminate solution or form, then you go and take the second derivatives and so on, then the third derivatives. So this is what we're going to do in our case. I'm going to come here and take the first derivative of both functions. So I'll do limit x converges to 1. And let's do first derivative. So we'll have 16x power 3 minus 6x power 2 plus 2x. And at the bottom, we'll have 15x power 2 minus 8x. Okay, just going back to the FE handbook, I would like to find derivatives. The formula I've used is this one. So when we have u power n, derivative of that is n multiplied by u power n minus 1. Just want to make sure you know where this comes from. And then let's move forward here. This is going to be equal to, let's substitute x with 1. So we're going to have limit, x converges to 1, 16 multiplied by 1 power 3 minus 6 multiplied by 1 power 2 plus 2 multiplied by 1 divided by 15 multiplied by 1 power 2 minus 8 multiplied by 1. And this equals to, we're going to have 16 minus 6 plus 2. At the bottom, we'll have 15 minus 8. And this gives us 16 minus 6 is 10, 10 plus 2 is 12, 12 divided by 7. It seems the correct option is B. So what we used here, we used a L'Hopital rule. And you use L'Hopital rule when you have the undeterminate form 0 over 0 or infinite over infinite. Great, let's move forward now. What is the maximum value of the function f dx equals to 2x cubed minus 8x squared plus 8x minus 12 in the interval 0 or x is greater than 0 but less than 3? Okay, so how to evaluate maximum or minimum or inflection for that matter? Okay, let me come here to the FE handbook. If I write maximum, we're going to get a lot of options, and you don't want to do that. But I usually write inflection, and that will take me straight to this. This is the place you want to be. Test for a maximum, minimum, and for inflection. And in our case, we have a test for maximum. So we're going to use this over here. And the way you do this, there are a few steps you have to follow. So first, we're going to have to do the derivative, take the first derivative, and then equal that to 0. And then the solution of that derivative, x, if you input it into second derivative, you have to get a negative value, and that is going to be a maximum for that function. So let's go ahead and do that in our case. I will take this function, let's say f, take the first derivative of the function, and equal it to 0, equals 0. So let's see. So the first derivative, I'll have 6x squared minus 16x plus 8 equals to 0. And now we're going to do the delta. Quickly, this is b squared minus 4ac. This equals to, b is 16, 16 squared, 256 minus 4 multiplied by a, which is 6, and multiplied by c, which is 8, equals. And I get a determinant of 64. And now we're going to calculate x1 and x2. x1 is going to be equal to minus b minus square root of delta over 2a. And x2 is going to be equal to minus b plus square root of delta over 2a. Perfect. Let's see, what are we getting here? So I'm going to have minus b. The b is minus 16, so I get 16 minus square root of delta is 8 divided by 2a. 2 times 6 is 12. So I'm getting here 8 over 12 equals 2. We can divide this by 4. 2 here. So I get 2 over 3. And in this case, I'm going to get 16 plus 8 divided by 2 multiplied by 6, which is 12. Here I'll have 16 plus 8 is 24 divided by 12. I get a value of 2. So here we go. We have the solution of this first derivative. And now we have to calculate the second derivative of this function equal to 0. So this is the first step. And then this is the second step, let's say. So the second derivative, we're going to come back here. So I'm getting 12x minus 16 equals to 0. And now we have to input based on the FE handbook. You have to take the solution of the first derivative and input it into the second derivative. And the solution that gives you a negative value, it's going to be a maximum. Let's do that. So I'm going to get now f of 2/3 equals to, if we substitute here 12 multiplied by 2/3 minus 16 equals, let's see, what do we get? Here, give me 4. 4 times 2 equals to 8. 8 minus 16 gives me a value of minus 8. It's less than 0. So this is a maximum. And let's try the next solution of 2 equals 2. 12 multiplied by 2 minus 16. This is 24 minus 16 equals to 8. And this is greater than 0. And if you go to the FE handbook, whatever the second derivative of A is greater than 0, that is a minimum. So in this case, not that we need it, but I'm just pointing out that this is going to be a minimum. Okay, this is maximum. So second derivative of 2/3 gives us a negative result. That means that this value is a maximum. So what we're going to do next, we're going to take this value and input it into the original function. So I guess this is step number 3. To find the maximum value of the function. So let's do that. So coming here, I'm going to do f of 2/3 equals, and I'll have 2 multiplied by 2/3 power 3 minus 8 multiplied by 2/3 power 2 plus 8 multiplied by 2/3 minus 12 equals, let's see what this is going to give us. 2 multiplied 2 power 3 is 8 divided by 3 power 3 is 27 minus 8 multiplied by 4 over 9 plus this is 16 over 3 minus 12. Okay, let's see what are we getting here. You should get a value of minus 9.63. So minus 9.63 would be your maximum value of the function. Now, I have to make a note. Since we are given this interval, x has to be between this interval. One thing I forgot to mention is that when we found these two solutions, we have to make sure that they are both within this interval over here, and they are. And now, since we have this interval, we have to also check what is the f of 0 and then f of 3. So we also have to evaluate f0 and then f of 3. f0, if you do that, you get a value of minus 12. And then f3, 2 multiplied 3 power 3 minus 8 multiplied 3 power 2 plus 8 times 3 minus 12. And this is going to give you a value of minus 6. Okay, so now we have 3 values of maximum, and we have to get the maximum value from these 3 values, and that's going to be the maximum value of the function. So let's see, let's say this. I'm going to write it somewhere here. Let's see if we can do this. Okay. So I'm going to say that the maximum of this function equals to the maximum value of minus 9.63 minus 12 minus 6 equals to the maximum value out of these 3 is minus 6. So just a note is, if we hadn't been given this interval, our maximum would have been minus 9.63. But since we have this interval, we have to check for the boundaries at f of 0 and f of 3, and we are getting that minus 6 is the maximum value of the function. So the correct answer is C. Okay, let's move forward now. This is what is the value of the following definite integral? We have integral from 0 to 4 of dx over 3x squared minus 5x plus 3. Let me write it down again because it's a little bit too tiny written over there. So integral between the interval 0, 4 of dx over 3x squared minus 5x plus 3. Let's see, how much is this? Well, now I will go ahead in the FE handbook and check the integral formulas. We have a bunch of integral formulas. Here they are. And, oh, these are the derivatives. Next page is the indefinite integrals. And I'm going to go through them. If you go through them pretty quickly, you're going to notice that you have these cases, 27a, b, c, and which is similar to what we have in our problem. We have a second degree equation at the bottom in all of these three cases. We just have to check what is b squared minus 4c, if it's equals to 0, greater than 0, or less than 0, to verify which case are we going to apply. So let's come back here, and I'm going to say b squared minus 4ac equals 2. And of course, this is a, this is b, and this is c. So let's go ahead and apply that. We're going to have 25 minus 4 multiplied by 3 multiplied by 3. And this is 25 minus 36. So I'm getting a value of minus 11, which is less than 0, which means, so b squared minus 4ac would give us a value less than 0. Excuse me, I will say, because I feel like they should have just left b squared minus 4ac. You know, you do one calculation and find out for everything. But anyway, so in my case, b squared minus 4ac I calculated is less than 0, which means I have to evaluate for 27a, this case. So let's write down how much is this interval equal to. We're going to have 2 over square root of 4ac minus b squared, tangent 2 minus 1, or arctangent of 2ax plus b over 4ac, or square root of 4ac minus b squared. Great. Let's write that down. So I'll say this results case 27a in the FE handbook. 2 divided by square root of 4ac minus b squared multiplied by tangent minus 1 of 2ax plus b, 2ax plus b over, and at the bottom is square root of 4ac minus b squared. 4ac minus b squared. Okay, let's substitute. So this is going to be equal to 2 over square root of 4 multiplied by a, 3 multiplied by c, also 3, minus b squared, which is minus 5 squared. Then we have tangent power minus 1 of 2 multiplied by a. A is 3, so by 3x plus b. B is minus 5, so let me delete the plus sign. I'll do minus 5 divided by 4 times 3, the same thing, times 3, minus 5 squared, square root of that, equals, okay, let's come here. This is going to be 2 over, let's see what we get here at the bottom. We should get square root of 11 multiply by tangent minus 1. Here we have 6x minus 5 over square root of 11. And all this, the interval is from 0 to 4. Okay. So now what we can do, we're going to bring 2, since this is a constant, 2 over square root of 11. We're going to take it in front, and we're going to do tangent minus 1, 6x minus 5 over square root of 11 from 0 to 4. And we're going to get to, let me write it down in the next row. It's just better. So I'm going to come all the way here. Let me see if I can do it very nice, very organized here. So 2 over 11. And then we're going to have, let me put this parenthesis, tangent minus 1 of 6. So it comes 6 multiplied by 4 minus 5 divided by square root of 11 minus tangent power minus 1 of 6 multiplied by 0 minus 5 over square root of 11. Okay, let's see what we get here. So 2 over square root of 11. Let's take the calculator and see what we get. So 6 times 4 minus 5, I get 24, 5 minus square root of 11 divided, and then we do arctangent of that. In order to calculate this, let me make a note. We have to have your calculator in the radian mode. So I'm going to do a note over here. Please have your calculator in radian mode. Otherwise, you're not going to get the right answer. So radian mode. Let me do that in my case because I haven't done that. Do radians. There you go. So now I'm going to start over. So 24 minus 5, 19. 11 square root of that divided. And then I do arctangent of this. So I get 1.397. Let's say 1.398. Okay, and then the next arctangent is minus 5. So I'll do minus 5 divided by square root of 11 divided, and then I'll do arctangent of that. So I get a negative value. So I have 1.4 minus minus. So this is going to become plus. All right. So I'm getting here multiplied by. So this entire parenthesis gives me a value of 2.38 equals. So let's see now. 2 multiplied 11 square root divided. So I get, after calculating this, I get a value of 1.437, which is eventually approximately 1.44. So looking at the answers, the correct answer is B. Okay, so here a few things we've done. We recognized that this form of the integral is case 27A in the FE handbook. Okay, let's move forward, I hope. Oh, and then the note that I made at the end is to remember to have your calculator in radian mode when you calculate exercises like that. Let's move forward. What is the estimate of the integral shown below if the trapezoidal rule is used? dividing the domain into 6 equal intervals. Okay, let's see now. If I go to the FA handbook and I will just say trapezoidal rule, it's going to pop up here. So this is the trapezoidal rule in the FA handbook. And we can follow the steps. Everything is given here. Let's see what it gets us. So for n equals to 1, we use this formula. For n greater than 1, which is our case, we have 6 intervals. We're going to have to use this formula over here. We have delta x. If we scroll a little bit more, you're going to find a formula for delta x is BO minus A over n, and n is the number of intervals between data points. Okay, where A and B is the extremities of the interval. So let's write the formula down for the trapezoidal rule. So here we're going to have delta x over 2. And then we're going to have f dA plus 2 sum of k equals to 1 all the way n minus 1 of f dA plus k delta x plus f b. I think that's it. So in this case, we have FDA, which are the extremities in the A and B. And then we have to also calculate for FDA plus K dx, which is, in our case, going to be FDA is F d0. And then we're going to have to calculate F of 1, F d2, of 3, of 4, 5, and 6. So f dA equals to f of 0 in our case, and then f of b equals to f of 6. And then all of this within this parenthesis, it's nothing else but we have to calculate f of 1, f of 2, f of 3, f of 4, f of 5, and then the number of the intervals we have is 6. So n equals to 6. So let's start with calculating how much is delta x. Delta x, as we've seen, is equal to b minus a over n. So we're going to have, let me write it down, b minus a over n. And in our case, b is equal to 6. So I have 6 minus 0 over 6 equals to 1. So I'm going to come back here. Or actually, let me calculate all of these. So f of 0 is going to give me a value of minus 12, right? And then f of 6, let me use the calculator because I don't really want to fill this page with this calculation. So I'll do 6 power 3, 2 multiplied, and then I have 6 power 2, so 36 multiplied by 8, and we subtract, and then we have 8 multiplied by 6, and we add, and then we have 12 minus, so I'm getting 180, and FD1 is 2 minus 8 minus 6 plus 8 is 2. 2 minus 12 is minus 10. So FD1 is minus 10. So FD2, we have 2 multiplied by 8. It's 16. 16 minus, there we have 8 times 4 32. 16 minus 32. 16 minus 16 plus 8 times 2, 16 gives me 0. So I have FD2 equals to minus 12. Next, FD3, 2 times, let's say 3 power 3, 27, 2 multiplied. And then we have 3 power 2, 9 times 8, 72, minus 8 times 3 is 24, plus 12 minus, so FD3 is minus 6. Let's move forward. FD4, 4 power 3, 64, 2 multiplied. 4 power 2 is 16, multiplied by 8. Then we subtract. Then we have 8 multiplied by 4, 32. 12 minus is 20. So FD4 gives you a value of 20. Let's start and do FD5. So 5 power 3, 125, 2 multiplied. 5 power 2, 25 multiplied by 8. Then we subtract. Then we have 8 multiplied by 5. That's 40. We add. And then 12 subtract. FD5 gives you a value of 78. So we finally did that, all of these values. Now we can come back to this formula and substitute and calculate this integral, or this integral using trapezoidal rule. Okay, let's do that. So coming here, I'll have delta x over 2, which is 1 over 2, multiplied by f dA, which is f d0 is minus 12, plus 2, multiplied by, and it's a sum of all, I have f d1 plus f d2 plus f d3 plus f d4 plus f d5. Okay, and then plus f d6. And then close the parentheses, and let's substitute with the values we have calculated. Here, instead of minus 12, I think I should have written FDA, which is FD0. Let's be consistent. Perfect. So now we have 1 over 2 multiplied by, and let's substitute. FD0 is minus 12 plus F2, and then we'll open the parentheses. FD1 is minus 10, FD2 minus 12, FD3 is minus 6, FD4 plus 20, FD5 plus 78, close the parentheses, plus FD6, which is 180, close the parentheses. And now let's just calculate, do the math. Let's see, I'm gonna getting just 78, 20 plus 6 minus 12 minus 10 minus 2 multiplied. Okay, and now we have 12 minus 18, 180, and I wrote 18, look at that. So here I have 180 plus, and then divided by 2, it's going to take this out. Okay, divided by 2, I get a value of 154. Okay, so this integral over here using trapezoidal rule is equal to 154. Okay, so the correct answer is A, 154. Now let's go to the next problem, which is a solution to the differential equation below. Okay, so looking at this example, I hope you recognize where to find this in the FE handbook. And let's come here. We're going to try and find differential, there you go, equations. And then I want you to recognize what type of differential equation you have. Several different differential. You get a lot of options here. Almost done. Let's get to the bottom of it. Come on. Okay. There you go. Differential equations. So I'm going to scroll down because I'm looking for the form that I have, which is not for first order. We have the second order differential equations. So my equation is of this form. So I have to follow all these steps over here and get to the solutions that's going to look something like this. I'm going to have to do these checks and then find the solution that is for my equation. So let's follow step by step what do we have here. Our equation is of this form. I know it looks a little bit different, but it is of this form. And then we're going to transform it into something like this. So let's do that. So let's write, this is going to be equivalent to 4r squared minus 7r plus 3 equals to 0. If I want to be more accurate, multiplied with CERX equals to 0. And since this cannot be 0, we're going to take this equation and equal it to 0. So we're going to say 4r squared minus 7r plus 3 equals 0. And this becomes a second degree equation, and we calculate the delta and the solutions for it. So let's do that. So now let's calculate these solutions for a second degree equation. First, we're going to calculate the delta equals to b squared minus 4ac. This is 49 minus 4 times 4 times 3. This gives me a delta of 4 times 3 is 12. 12 times 4 is 48. So this gives me a delta of 1. So now I calculate the solutions R1 and R2. R1 is equal to minus b minus square root of delta over 2a. And R2 is minus b plus square root of delta over 2a. Okay, let's see, minus b, that gives me 7, minus 7, minus square root of delta is 1 over 2a, 2 multiplied by 4, that is 8. So 7 minus 1 gives me 6 over 8. And R2 gives me 7 plus 1 over 8 equals to 1. So I have a solution of 6 over 8. This can be simplified. If we divide by 2, get 3 and 4. This gives me 3 over 4. Perfect. So I have the solutions. Now what I have to do, I have calculated it, R1 and R2, and now I have to see what is the value for a squared and 4b. So let's calculate for a squared. So A squared equals 2, and then 4B equals 2. Now pay attention. We have done the second degree equation for which this is A, this is B, and this is C. Now looking at this second order linear homogeneous differential equation, this is A and this is B. So let's not confuse this. So coming back to our problem, we're actually going to have this as A, right? And then this as B. Okay, so let me write down A is equal to -7 and B is equal to 3. Perfect. So A squared is going to be equal to 49 and 4B is 4 multiplied by 3 and it gives me 12. So if we were to compare this, I get that A squared is greater than 4B. So this is the case I have where A squared is greater than 4B. So the solution is of the form y equals to this. Let's write this down. Okay, so this means that the solution is y equals to, let's see, we get C1 e power R1x, C1 multiplied by e power R1x plus C2 multiplied by e power R2x. Let's substitute what we know. And we know the values for R1 and R2. We don't have enough information to calculate C1 and C2, so we're going to leave these two like the way they are. So this is going to become C1 multiplied by e power R1, which is 3/4. Let's write as 0.75. So we have C1 multiplied by e power 0.75x plus C2 remains the same multiplied by e power R2. R2 is 1. So I'm just going to write x. Okay. And this is the solution we can calculate and we get. So come back here to the ABC options. We see that it looks a little bit different. So the thing is we cannot calculate C1 and C2. So let's ignore that. What we have is the R1 and R2 in these formulas. So let's check for that. So we have e power 0.75x and e power x. Let's look at the first option. We have e power 3x and -4x. Let's look at this second option. If you pay attention, we have e power 0.75x and e power x, but it is minus. And that's okay that it's minus because we don't know the value for C2. So if C2 is negative, then this is going to become minus. So it seems like B would be our correct answers. I would quickly go to the next C and D option, and I can see that they don't match. So it seems that B in our case is the correct answer. And that was the last problem for today. I hope you found it helpful. If you did, as always, I'm going to ask you, please subscribe and give it a like because this helps put this video in front of more people just like you. Have fun practicing the FE problems and I will see you next week.